Referring you back to the pictures that we drew in the last video of the cosine function extended, we're going to answer the following questions just by looking at those graphs. First, we'll find part A, the y-intercept. Now, there's only one y-intercept. It is the point where the graph of y equals cosine x crosses the x-axis. In other words, the y-axis. It's the x value where it crosses, and we're going to write it as an ordered pair. So go back, look at the picture, and then write the ordered pair. Of course, the x-coordinate is going to be 0 because that's the location of the y-axis. But what is the y value where it crosses? And the answer is the ordered pair xy is equal to 0 for the x-coordinate and 1 for the y-coordinate. Just look at the graph and you should be able to see that. Let's go on to part B. In part B, we're going to find out by looking at the graph, for what number x, when we restrict x between negative pi and positive pi, is our graph decreasing? Now remember what it means to be decreasing. It means as you move along the graph from the left to the right, to be decreasing means you're moving downward as you move horizontally from left to right. Look at the picture. Where does that occur between x equals negative pi and x equal pi? Well, it certainly doesn't happen on the first half of that interval from negative pi to 0. It doesn't happen there. That's where it's increasing. It's decreasing between 0 and pi. So if we wrote that in inequality notation, we would have 0 less than x less than pi. In other words, on the open interval from 0 to pi, the function is decreasing. Part C, what is the absolute maximum value for y equals cosine x? Now remember, absolute maximum is asking for the highest y value. And it's clear in that picture. The answer is y equals positive 1. It's always the maximum. It occurs many times, but that is the highest value of y that the graph attains. Part D, for what numbers x, when you restrict x values between 0 and 2 pi, does the cosine of x equal 0? For what values of x does the cosine of x equal 0? Now remember, we're restricting our x values between 0 and 2 pi. Well, between x equals 0 to x equals 2 pi, the cosine value, the y partner, reaches 0 only at the values x equals pi over 2 and x equals 3 pi over 2. So write those down. Write the x values down that you see in the graph. X equals pi over 2, x equals 3 pi over 2. Part E. For what numbers x, when we restrict the values of x between negative 2 pi and positive 2 pi, does the cosine equal 1? Okay, now we're looking at the same x interval between negative 2 pi and positive 2 pi. We're actually looking between negative 2 pi and positive 2 pi. It happens, when we include those endpoints, negative 2 pi and positive 2 pi, it happens 3 places, exactly at 2 pi, negative 2 pi, at 0, and at positive 2 pi. Those are the values of x for which the graph reaches 1. The y value equals 1. Okay, let's go to part F. On that graph, for what numbers x, when we restrict values between negative 2 pi and positive 2 pi, does the cosine of x equal the square root of 3 over 2? Now that's a tough question. I cannot just look at that graph and say exactly where the y value is equal to the square root of 3 over 2. I mean, I know its approximate location. I know it's less than 1 and it's getting close to 1. But it's really difficult to say. But that number, square root of 3 over 2, it sure sounds familiar. So the first thing I'm going to do is think about one of our special triangles that contains the square root of 3 and 2 as its sides. And that would be the 30, 60, 90 triangle, pi over 3, pi over 6, and then the right angle with the sides 1, 2, square root of 3. Let's reproduce that right here in this picture. 1, 2, square root of 3. Now, look at that. We're asking for what x value does the cosine of x equal square root of 3 over 2. So I'm looking at this picture, and I'm remembering that cosine on the right triangle is the adjacent over hypotenuse. The hypotenuse here is 2. I want the adjacent side to be the square root of 3, so I'll get the square root of 3 over 2. Well, that means I'm going to have to choose pi over 6. Because if you look at the right triangle, for adjacent over hypotenuse, the cosine of pi over 6 in the triangle gives us a square root of 3 over 2. So I know that between negative 2 pi and positive 2 pi, that one value I'm sure of, x equals pi over 6, will give me the cosine equal to square root of 3 over 2. Now to find the other ones, I'm going to do just as I did in the sketch. I drew a dotted line horizontally. So you look back at the previous video and you'll see that I drew a dotted line across all the height, all the y values that correspond to the same y value as pi over 6. In other words, they all have the same cosine values. And if I could possibly, let me try to reproduce what I drew here. It's a little bit sloppy, so you might want to just check out your own work. So you see, it occurs to pi over 6 units right here to the right of the 0. But it occurs again immediately to the left, the same quantity of units, negative pi over 6 on the left side. It occurs again on the right side at 2 pi minus pi over 6. Right? That's 2 pi minus pi over 6 will give me that value on the right. And then on the left it occurs again at negative 2 pi plus pi over 6. So it occurs at pi over 6 and negative pi over 6, and again at 11 pi over 6 and negative 11 pi over 6. And I really was getting that by looking at the symmetry. The distance from the high points on the left and the right would give me the same cosine value, square root of 3 over 2. So that means my answer would be plus or minus pi over 6 and plus or minus 11 pi over 6. And then part G, find the x-intercepts. Okay, well, they're going to repeat over and over again. And that's kind of a difficult question. Yes, they're going to repeat over and over again, and they actually happen every interval of 2 times k plus 1 in parentheses times pi over 2, where k is an integer, which means k can be any number, 0, 1, 2, 3, or negative 1, negative 2, negative 3, any whole number, positive or negative or 0. And if you want to see what I'm talking about, let k equal 0 and see what number you get, and you'll see that's a y-intercept. Let k equal 1, and you'll get another x-intercept. Let k equal 2. Let k equal negative 1. K equal negative 2. It's going to keep giving you x-intercept, and that's just a compact way of expressing all of those infinitely many x-intercepts.